We're told that we've got a binomial distribution x, 50 trials, probability of success 1/6. The probabilities p x equals r for r equals 0 to 50 are given by the expansion of this thing here. This is a binomial distribution. This is a binomial expansion. The first question is basically asking us, do we understand the link between them? Now, there is a formula for binomial expansion given in the formula book. I'm just going to write out the first few terms for it. It's going to be a to the n plus nc1 a to the n minus 1b plus nc2 a to the n minus 2b squared, etc. And what this is essentially is that this is the probability that there are 0 successes. If I just get only failures, there's only one way along the tree diagram I can get that. Then this would be the probability that x is equal to 1. One success, n minus 1 failures. There's actually there's different ways you can permutate that to get these failures, because you could have success, failure, 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 or you could have failure, success, failure, 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 and so on. So it's all the way how you do permutations. I've gone on for quite a while. This is like literally a 1-mark question. It's just asking you, like, can you understand that? So in my case, A is actually the probability of failures. So A would be equal to 5/6, and B would then be equal to 1/6, my probability of success. Oh, and N would equal 50. That is my answer, and that is the link between the binomial expansion and the binomial distribution. Note that I could actually have done it the other way around, and I could have said that A is 1/6. That's gonna, you'd get the same kind of. Remember, like if you, I don't know, you actually to sort of decide what the failure and success are. It doesn't really matter, but yeah, you could have gone with this instead. That would have been accepted, and obviously n is 50. Okay, let's look at the next part. A student has an ordinary 6-sided dice. They suspect that it's biased so that it shows a 2 on fewer throws than it would be if it were fair. So it's biased against a 2. The probability of getting a 2 would have been 1/6 normally, but it's going to be less than that. They suspect it's going to be less than that. In order to test the suspicion, it's throwing 50 times and the number of 2s is noted. They then carry out a hypothesis test at the 5% level. Write down suitable hypotheses for this test. So our null hypothesis is going to be that the probability is actually 1/6, it's not biased. And H1 is then going to be that the probability is less than 1/6. We're looking at whether there are, it's biased against 2. Okay, what does it then say? Determine the rejection region for the test. 5% significance level. So this is the number of 2s that we would have to get to reject the null hypothesis, essentially. And what we can do is we can go to distribution. It's going to be binomial CD. Use the list function and look at some probabilities of x being less than or equal to. Actually, we've not. Sorry, I'm getting ahead of myself. After you've got your hypotheses, we should actually technically assume H0 is true. So x will follow a binomial distribution 50 and 1/6, which is what we're given right at the start. Right, now we're going to find the probability that x is less than or equal to some values. And what should we look for? I don't know, it's actually quite hard to know what to look for. We're expecting it to be quite small, so it's going to be very small. So I might just go for up 1 to 10, let's say. I can't look at it and just know, but I think 10 is definitely going to be big enough. And I'm looking for where it crosses over from below 5%. So P is 50, P is 1/6. can actually, it's very small, the cutoff. We see the probability that x is less than or equal to 3 is 0.0238. Which is less than 5%, or 0.05. Whereas the probability that x is less than or equal to 4, always write the 2 in between the cutoff. This is 0.0643. So basically, I just want to remind you, like, what does this actually mean? We're saying that there is only a 2.4-ish% chance that if we rolled this dice 50 times, that we would get 3 or fewer 2s. Okay, and so if that did happen, there's such a small chance of it happening that it must be that actually it is biased. It wasn't 1/6 to begin with. So that you would reject H0. Whereas if you scored 4, essentially, if you scored 4, get 4 2s on your dice, well, actually, there's a 6.4% chance that you'd score 4 or fewer 2s, and there's enough of a chance that that could happen. It's bigger than the cutoff that we would actually not reject H0. We're not actually asked to conduct a test here. We're just asked to determine the rejection region. So I've shown the key probabilities, and the rejection region, sometimes known as the critical region, is simply going to be x is less than or equal to 3.